Okay, probability trees. A very, very famous exam question here, which caught many students out in the year it was asked. In this version of it, known as Becky's Sweets. Always worth a really good read through the information here. Let's digest actually what's happening in this question. We've got a total of n sweets. We've got 6 of those being orange, and we've got the rest being yellow. We'll come back to that in a moment. Becky takes at random a sweet from the bag, bit of context. She then takes another sweet at random and also eats it. Quite important that she eats it because that's going to change how many sweets we have in the bag. We're given the probability that Becky eats 2 orange sweets. All we need to consider in this question then is the probability that she eats 1 orange sweet and then the second sweet she eats is also orange. You may like to, if you prefer, to write this information into a probability tree. So the first sweet is either orange or it is yellow, and the second sweet is then either orange or yellow, depending on what she picked on the first sweet. But just go back to what we said. We said that she only needs to pick 2 orange sweets. We therefore do not need to work out any other probabilities in this question. First sweet she picks. We know there's a total of n sweets in the bag, 6 of which are orange. So probability of 6 over n. Now she eats that sweet. Therefore, there's only 5 orange sweets left after the first one, but the total number of sweets is also reduced by 1. So we have a total of n minus 1 sweets. On a probability tree, we should know that to go along the probability tree, we're going to multiply the 2 probabilities, because it is the probability the first sweet is orange and the probability the second sweet is orange. Multiplying fractions, we know that that simplifies to 30 on the numerator and n minus 1 on the denominator. We also know though that that probability is equal to 1/3. Let's go to the question. We haven't actually discussed what we're showing. We've got a bit of a quadratic to show. There's no fractions in there, so we're going to rearrange this so we no longer have the fractions. So taking my 30 over n minus 1 and my third statement, I'm going to start rearranging here. I'm going to times both sides of this statement by 3, and I'm going to times both sides of this statement by n and n minus 1. Several different ways you could notate this, but I get 90 on the left side, and I get 1 lot of n take away 1 on the right side. Starting to look more like the statement we're showing. Going to expand my brackets, so n squared subtract n, and then I'm going to take away 90 from both sides, leaving with 0 on the left, and n squared, take away n, take away 90, QED. If you prefer, you may write the left and right hand sides the other way around. In part B, notice we could do part B without having done part A. Really useful point for your exam technique. We've got a quadratic is equal to 0. Many techniques you can do. The first one really should be considering your factorising. So I'm looking for 2 numbers because it is 1n squared that multiply to negative 90 but add to negative 1. So take away 10 or negative 10 plus 9. I'm solving this quadratic, so n equals 10 makes my first bracket 0, and n equals 9 makes my second bracket 0. But we've got to be careful here. This was a contextual question, a question about real probabilities, where n represented the number of sweets in the bag. We cannot have negative 9 sweets, and therefore n equals 10 is the only solution for the context of this question. Becky's Sweets. Famous problem, lots going on, really worth going back and making sure you're happy with every part of that question.